In this video, I want to make a very important distinction that may not strike you as significant initially. When we look at imperative languages, and can you remember what we mean by imperative? Languages like Java, C++, etc. These languages, when you write a statement, a line of code, a statement, you execute that statement. So you run it. Now, that's a very different type of concept, and I just want to draw the distinction out that with functional programming, which is what this module is all about, we don't execute statements as we would do with imperative languages. We evaluate them. Evaluate is almost like decode. It's almost like work out what they're actually saying and go through and try to understand them. A distinction I found in the past quite useful is that, and this is just to preface a remark, is that imperative languages often are required to code mechanisms, basically how you do something. So if you want to evaluate something, you've got to create a mechanism to do that in an imperative language. So in Java, what you'll find is that these mechanisms are managed and controlled within objects and methods and so on. With functional programming, the mechanism becomes irrelevant. The how is not the issue. It is simply the what. What does the statement say, and how can we evaluate it? So that means that we aren't worried about how you do it. We need to define what it says. So let's try to make this distinction clear before we just look very briefly at the example from the lecture slide. So we had a function before. We called it twice. Hopefully you can see that, twice sum. We had two integers, first parameter, second parameter, and then the result, which was a parameter. Remember, the result could always be a float, for example. We then defined the function. Now, what we're doing here when we write this, x, y, is we're defining the number of parameters, and we're saying that they are evaluated in this expression. If you remember this from a previous week, now that is not a mechanism. That is not saying how it works. It is simply saying what happens to those two parameters. So it's a very important distinction here. With imperative languages, we execute them. We need to also define mechanisms of how we are going to go about executing these lines of code. So this is why we create methods and objects and so on. With functional, we evaluate them. How it does it is not our concern. What it needs to do is our only concern. So this, in many ways, is important to recognize that with functional languages, we're dealing at almost a higher level of abstraction than imperative. We are not getting our hands into mechanisms and writing mechanisms. We're simply stating what we want the function to do, okay, or what we want it to evaluate. So keep that in mind. Let's have a look at the example from twice sum from a previous session. So that just defines the parameters, the constraints of what we want to do. They're the two input parameters. And so as we know from a previous session, you should hopefully be confident. And this would go typically into your console window. And we can evaluate it. I'm not sure if you noticed, I left out the double colon when we were defining that statement here. So I've inserted it back in. So you may have noticed it was spotting an error in my code. Pay attention to the syntax. There we go. Very simple function. We define it. We don't say how. This is simply a statement to evaluate, right? Break it down into steps. And they're our input values. So what I'm going to do is just match the input values that are in the lecture slide So we're expecting 16. So let's evaluate it in separate steps. And let me get my other screen open. Okay, so let's evaluate that statement. So our statement is x, y are the input parameters going into this statement. This is the statement to evaluate. So in order to execute, I'm misusing that, in order to evaluate, excuse me, that's one parameter, and the second parameter is 2 plus 6. So there's your y, there's your x. Okay, so let's replace the formal parameters inside this statement and go through the step-by-step process of how it's evaluated so it's clear for you. So if we replace for the x and replace this for here, we end up with a statement that looks like this. I'll do it in a different color. It is 2 times our x is 4 plus, and our y is 2 plus 6. Okay, so let's go through how that's evaluated. Well, the very first thing that we have to do is, first of all, use the sequence of brackets. So we have to evaluate this. So what we end up with is 4 plus 8. Now, what you notice is this is mathematics, this is arithmetic, this is evaluative statement in how we go about working this through in maths. So according to the rules, we then process those two. 4 plus 8 is 12. So we end up with that statement there. 2 and 2 times 12 is 24. Not that we need to verify it, but let's pop to our twice sum. So our first parameter was 4. And our second parameter, which we identified using a bracket, was 2 plus 6. And as you can see, it evaluates it in exactly the same way. So the purpose of this video is just to make clear that what we're doing is evaluating an expression. When we add the values in, we're evaluating it. The process of evaluating it relies on mathematical rules or rules of arithmetic. We have not had to, in order to evaluate it for Haskell, if you look over here, we haven't had to write these steps or write code to execute this function. It's not the right concept. We are not executing, we are evaluating. We are not worried about how. At this stage, it might be a bit confusing because you think, actually, that does say how, and you look like you've done something very much like a how. So that may not, in the end, be that useful to you. But keep that distinction in mind. With functional, we are evaluating what the functional statement says. With imperative language, we typically can also evaluate, but in the process of it, we're actually executing a block of code, because we often need to have the mechanisms of how we are going to go through that process. So if we wrote twice sum, we would have to write steps out and have return statements and all this kind of stuff, return it back to a place where it's going to be outputted to the screen and all these kind of mechanisms. Okay, so let's stop there and move on to the next one.